We are coming to that. We are coming to that now. So, for wired networks, we have various cables that can be used for wired network. I'll pass these cables round so you see what a cable looks like. So, we have various cables that can be used for wired networks. Various cables can be used. Please pass it backward. Keep passing the other one, please. So for wired network, we have what we call Cat6 cable. What you are passing now is called Cat6 cable. You could call it untwisted, twisted, whatever, but the general name is called Cat6 cable. Cat6 cable, CAT and 6. Cat6 network cable, that is the general name for what you are passing around now. And Cat6 cable can only be used to connect to a distance of 100 meters. For the cable you are passing around now, it can only do a connection of 100 meters. 100 meters. Once you are connecting more than 100 meters, you will now use that switch that you are passing around. So that is like an extension, just like extension cable. Once it's about to exceed, if you have an extension of 5 sockets and there are 10 people in this class, it means you have 2 extensions. Once you connect 4 people here, you connect the other extension to the last place. Then others can connect. Am I right? So that is how it works. So once Cat6 cable goes beyond 100 meters, you just need to get that device you are passing around, put it in the center, then connect the next 100 meters. With that, you can connect maybe around this entire building. For instance, you see that device at the back. That device at the back now, let's explain what it does practically. We talked about extension cable. There's an internet in this facility that is controlled from one particular office somewhere. Now, in cybersecurity, when you go to network design, cost is a very important factor. Cost in terms of finance. Then also troubleshooting. Please, let's be together. Cost and troubleshooting is very important. So assuming we were in this class and the server room is in another room, if you check each of your tables, you see a particular box which will explain what that box is in. The box is different from the extension box. Have you seen it? That is for network. So this class is actually used for CBT exams to be done with the head of cable, one cable to one computer. They had an option of running all the cables to one particular office. So imagine running 200 cables from this class to one office. Imagine what would happen. The trunking and how you move all the cables. Now, in all the classes, maybe 6 classes here, you are running 600 cables to one office. It does not make sense. If there's fault in any one, it's difficult to trace. What did they now do? They bought plenty of those switches you are seeing there, because every switch has about 24 or 48 of those ports. We call it ports. Those holes you are seeing there are called POLT ports. Every of that device has about 24 of those holes. So they lump up a lot of them there. So they now connected the entire class to that place. Using the principle of extension sockets, only one cable now will go from this box to that server room. Because in this box, there is about 4 switches. Each of them, when it takes 23, the next one will loop to the next one. The next one will loop. Then the final one goes to that room over there. That means time for troubleshooting. If this one is bad, you can see a number is written there. You can easily go to the same number there and trace the cable. Do you understand how switch now works? It just works like extension socket, allowing you to extend your network with the use of cable. Fiber optics cable can go as much as 100 meters. Sorry, 100 kilometers. So as small as fiber optic cable is, it can go long distance. That is why it is only fiber optic cable they use for intercity projects and intercampus projects. If you are connecting this building to ICTC, you don't use Cat6 cable. Maybe from the main server room now, they will now run fiber optic cable, dig the ground till they get to ICTC and connect it to the main internet source over there. So that is what we call different types of, those are the different types of network cables that we have available. So this table, please, is very, very important. This table is very, very important. When you see it, when you get this slide, please, if you want to cram it, okay, let me see, is this the one? Yes. If you want to cram this thing, you cram it. Though when we come to practicals, we'll do it again. I don't know how many of you took note. When I pass this cable around, there's a pin on it. When we are learning how to fix this pin, you notice that we have 8 small cables inside here. All those 8 have their colors. When we are putting this pin, we must follow those colors one after the other. If not, there's problem. If you don't follow those colors one after the other, it won't work. Don't worry, when we go to the practical section, we would know more about that. But this is the color code. And this is the one you have to know, not really to cram. Because we would ask you the color coding during exams. What is the standard color code? We may tell you green, yellow, brown, up to 8. Or we'll bring the, so you now have to choose the exact color code for cabling. Already I've explained to you, but this is how wired networks are. I've told you what is a switch already, which is this. This is the physical representation of a switch. 3 computers, printer, laptop. This is it. What I was explaining, I've shown you the equipment, and these are the computers here connected to the switch. This is still a switch here connected to the switch. Now, wireless network. What she was asking, a wireless network actually uses radio waves instead of wire to communicate. Wireless networks allows equipment to be connected without network cables, making it very easy to deploy. These cables we are running can take a lot of money and time to construct. But if I come to this class and simply on my hotspot and tell everybody to connect, I have done all what that device at the back is doing. If I give you the Wi-Fi key to this device now, all of you can connect, meaning that I have eliminated the need for that guy at the back. It's as simple as that. Wireless uses radio waves to communicate instead of cable. Someone would ask, what is the advantage of wireless over wired? Can someone assist us? Why do you prefer wireless to wired, or why is wired preferred to wireless? Okay, that's why wireless is preferred and cost efficient. Okay. So why is wired preferred to wireless? Another person.
Wired is preferred to wireless because wired is safe. Mostly safe from attacks. The wireless is more prone to attacks.
Okay. Okay. Another reason. Why is wired preferred to wireless? Okay. No interference. Radio waves. You know, when you are talking about Wi-Fi, it's very, very dicey. Wi-Fi is very, very dicey. Now, let's see this. I put on my hotspot. The people in front will browse faster. The people at the back will browse slow because of distance. This one will see full bar, they will see 1 bar. Will the connection speed be the same? So when we go to network characteristics, I'm not yet gone to that. We'll learn about the different network characteristics, and it is those network characteristics that will help us to determine if we should use wireless or wired. We'll go to that much later. But for now, just know that wireless connectivity allows networking without using cables. This is a typical example of wireless. You just have an access point, then all your phones and computers connect through the Wi-Fi. The next one is called hybrid. Hybrid simply means a combination of wireless and wired. Hybrid is a combination of wireless and wired. Hybrid, combination of wireless and wired. When do we use hybrid? I came to this class and I only have this field with 24, and we have 200 students in this class about to write a test. Only 24 people can connect with cable to that place. What do I need to do? I simply bring that. Maybe my computer is connected here. My computer has the exam question. I put it on number 1. 20 people are connected from number 2 to maybe number 21. And the question is, how would others write the exams? I simply carry that MTN stuff, plug the cable in the next one, and 60, if it can allow 60 people, it means that 60 more people can connect to that same examination. That is hybrid. Hybrid is simply a connection or a combination of wired and wireless connectivity. So hybrid connectivity is done using the help of an access point. The devices that help you establish hybrid connectivities are called access points. Please, let's pass this around. I just have 3 of it. Okay, let's pass this around. They come in different shapes and sizes. Some of those access points, we call it access points. Some of those access points can be used outside. Some can be used inside. That's what we call outdoor and indoor. Outdoor and indoor. Like the one they have there. Please pass it quickly. The one they have there is radar proof and radar resistant. So that one we can mount it outdoor. Even if rain touches it, nothing happens. But these ones are indoor. So wireless connectivity is made possible with the help of an access point. Wireless is done with the help of an access point. So in hybrid connectivity, if you notice, you see a wireless access point here. You see my modem. You see the access point. You see my switch here. Everybody can browse on that network connection. Everybody can browse on that network connection. The next thing we'll be looking at is this: network topology. Network topology. Sorry, I think next class we may have to write. I'll bring the marker. Network topology. So in network topology, what are we saying? Now, remember this. We are in a networking class, and you have to be a network engineer to design these things. Network topology simply means the layout and the design of computer cables and network devices. I gave you an example. I came to this class and I want to do a network design, or I was given a contract to network this entire test form building. And I was told to bring a network design. At the same time, let me look for... I was told to bring a network design and also bring the equipment that I am going to use to design that network. So what do you think I'm going to do? Sorry, I don't have a marker here. Let me see what we can do. You have a marker in your bag? Okay. Okay, thank you. Thank you. Okay, I'll just manage this. So in network design now, first of all, I came to test form building. They told me to network this entire structure. What should I look out for first? I'll ask them, what is this? What is the networking to be used for? I was now told computer-based test. What is the class carrying capacity of every class? 80 people. So from what we just discussed, I prefer to do a physical cable infrastructure per class and put in a switch in each class so that every class can operate independently. Maybe tomorrow, Faculty of Computing want to use this building. An advantage of segregating the connectivity in each class, if I come here, maybe cybersecurity is here now, I can carry my own router and simply plug there and everybody will browse. I don't want infotech to browse with my router. Means that once I connect this to this one, I will disconnect the cable linking us to the server room. That is when planning comes into play. Infotech can do their own thing without contacting us. That is what Wi-Fi may not readily help us to achieve. Are you seeing it? So, whenever I need to access the main server room, I plug back that cable that is taking us out. So, in network topology, they may ask you to draw a design of how you want to do your network. In my own case, I can decide to put a switch here and say all the computers should connect themselves. Some other people will tell you that, no, don't do it that way. You are wasting funds. Why must you buy a switch? They will now tell you that put the network on my own computer. Then they will tell me to connect a cable from my computer to his computer. He may now connect a cable from his own computer to his own, and so on and so forth. What will happen? It means that once his battery goes off, the other person will be cut off. That is it. The other person will be cut off. So topology of a network actually determines the layout of the cables and other devices. And we have several topologies. We have the bus, we have the ring like in a circle. We have the star, we have the mesh and the wireless. Those are some areas you may have to read up so we don't spend a lot of time there. This is the bus here. The bus, we told you that we use a single cable and everybody keep tapping to that cable. See it here. Everybody keep tapping. What will happen? It means that once there's any break in the cable, the entire connectivity goes down. Are you seeing it? That means this is not really effective right now. But it is the cheapest to maintain. The bus technology is what we use in electrical. Most people that wire electrical houses, this is what they use. They will just run, in fact, our hostels, that's what we all do. If you go to the hostel, you just see a cable running from one socket to the next one. When you go to your room and you want to create another socket point, you look up, everybody's an electrician, you see a bulb. You simply lose the bulb. Tap the cable, drop an extension there, you plug back the bulb. What is the implication? The implication is that if I go and off light, your socket has gone off. That is bus topology. But it is very, very cheap to deploy. Instead of running every cable to the middle of that big DB, like this stuff, you know, this is the control unit. Instead of running every cable from your room to this place, you simply start tapping. That is bus topology. It requires less cable and does not require any specialized equipment, but it's very difficult to troubleshoot. We have the logical ring topology. In logical ring, or in ring topology, sorry, data travels in a circular fashion from one computer to another. Advantage: cable faults are easily to locate. They are easy to install, but expansion to the network can cause network disruption. And like I told you, a single break in the cable can disrupt the entire network. Just one break in its own place can disrupt the entire network. Now, what is a star topology? Star topology is what we demonstrated with a switch.
Both topology and the bound topology. Is it like same connectivity that you connect this system to this one?
No, look at it now. Look at it here. Boss, a cable is just running. You tap to your own side. Tap to your own side. But in ring, it is passing through each computer, like what I explained here. You connect from this computer to this computer. This one connects to this one. This one connects to this one. Connects to this one. That is ring.
How is it? Both topology is like wire to run this thing. So everybody's tapping to it.
Yes.
This person is one wire also. How I think that.
Yes, it does not affect, but once there is a break in the central line, if there's a break here, it affects these people. If the source is coming from here and there's a break here, it means it affects all these other people. So both ways, that is, those two methods are not too standard. We now have the star topology. In the star topology, every device is connected to a central device like we explained, which is called a switch. And everybody connecting uses its own cable. And if there's a single point of failure, it must be just the switch. Meaning that if there's no network, you check the switch and you can just replace that switch and everybody comes back online. Am I right? Everybody comes back online. It can easily be expanded without disrupting the network. You can expand it. It's just a matter of adding another switch here, disconnecting just one person so that you use the person to loop to the next one, right? And everybody will start working. Cable faults only affect a single user, but it requires more cable and it's more difficult to implement. We now have a mesh topology. In a mesh topology, every computer connects to every other one. That is what data center does. Every computer connects to every other one. And we have a very high level of redundancy. Redundancy means the system will always be available. No point of failure. You can see it here. When you are sending a message, www.google.com, they always like using mesh. So in Google servers now, everything on this computer is also on this computer. Everything here is here. All the computers are backing up themselves. So that if me in Nigeria, I sent a message, google.com, the server in South Africa is bad. It quickly, since from what you see here, every computer is connecting to itself. It will simply, if this one gets bad, it simply connects here. If this route gets bad, it simply connects here. If the other one, you can see it. It's a cyclic mesh connectivity, but it's very, very expensive to maintain. We now have different types of networks. How many types of network? We have 5 major types. Personal area network, the one I just put on my hotspot and everybody can connect. Local area network, the network in a class is local. The network in the university is local. When you say something is local, it means localized to a community. We can even say Nigeria is local, depends on how you want to look at it. Nigeria may be regarded as metropolitan or local, depends on how you want to look at it. If you disconnect Nigeria from the entire African continent, it means automatically we are a local area network. We just want to share files amongst our own self. We now have metropolitan, those big cities area network. I've explained it already. These are the diagrams surrounding the local area network again. I explained this already where we have building 1, building 2, building 3, all of us connected amongst ourselves. Now, let me explain one concept. Please, let's mark this. I've explained what is a switch, right? I've explained what is a cable. There's another device that helps us to establish local area, that helps us establish a network. That device is called a router. Before you bother yourself with what is a router, how does it work, let's bring our brain back to electricity. I love using electricity to explain it. Remember, please, let's be very attentive to this. Remember, I'm unplugging this because the two devices have UPS, have power bank. Please, let's all look at this. I want to explain a router because after now, we'll do practical with the router, and though not today. This is an extension, right? It's an extension. On this extension, I can connect all my phones and laptop if it's up to 50. Am I right? Am I right? Yes, can I connect air condition to this extension? Why? Why? Maybe if you see a condition mouth, it has round mouth, which is its socket is not here. But there can be another type of extension with those round mouths where you can now connect air condition, but you cannot connect your phone. In that case, I may not even plug this thing here. I may go to go and plug it in an air condition socket. Now, in that same vein, if you cut this cable into two, you notice that the cables inside are very thick. In measurement, they call it 2.5 mm cable. They're very thick because it's carrying laptops, phones, and other devices. If you open up the power cable of an air condition, it is thicker than this one. Those of you that tap lights, have you seen the cable used for lights? Very, very light because it is carrying something small. Now, what do you think actually helps us to do all of that? It is this guy here. This guy is called a distribution box. A distribution box. The lights coming in from NEPA. I'm explaining it now. After now, please don't go and form electrician in your house. So the lights coming in from NEPA enters this box. If you go back to your houses, please, all of you should go and look for this box. Some of you may not see this big one. You may see one small one in your lodge. Hope you see smaller ones in your lodge. Yes. That you now see your changeover for NEPA and Gen connected to that small one. Whenever your house have problem, you call electrician. Where do they used to go to go and open that box to go and check if these things are in on and off position, or if they will not tell you your breaker don't burn. Have you heard that statement? Let me now explain what this box does. The light coming in from NEPA enters this box. This box now has provision for heavy appliances, medium appliances, and light appliances. So all your fans and bulb could be connected to maybe that upper part. You are seeing three things there. Each of those three boxes, maybe one controls all the fans, one controls all the lights, and one controls maybe another thing up. This other side, maybe the one for air conditions. So the cables coming in from here must always go to air condition because the cables have to be very thick. This other one now, maybe the one for sockets. So from this single box, electrician already knows that all air conditions must connect to that side. All lights and fans must connect to this side, and all sockets to connect to the downside because this is a distribution box. So when they carry, let's assume that it's a laptop to configure this box. When they use their own imaginary laptop, they are telling the laptop, let me show you this before I pass the equipment. Please switch with that switch. Have you returned the switch? The switch that we're passing around. Sorry? Okay, I've seen it. So let's look at this. Let's look at this. So assuming I am the electrician working on this, please, this is very important. Assuming I'm the electrician working on that now. As an electrician, I'm saying that when I press my computer, I have given my computer command that this number 1, any cable connected here should have the current that can power only light. Any cable connected to number 2 should have the current that can power only air condition. Any cable connected to number 3 should power switch. So if you now carry air condition that is meant to be number 2 and plug in number 3, that is when you now see cables are blowing. So what usually happen in your hostels is that you go and tap light from light bulb to power hot plate or ring boiler. The next thing you notice that the cable start burning, and you now start asking yourself what has happened. It's because when the guy that was the network guy that was configuring that place, he told the place that only electrical lights should be connected there and not ring boiler, because ring boiler needs a very high type of cable. So in that same vein, a router is actually used to interconnect several locations together. Why is it so? Now, there's a very slim line or a very slim difference between a router and a switch. Because I am still going to pass this round as a router, that's why I'm explaining this now. I used this and told you that this was a switch before now. Now I'm telling you this is a router. It depends on what they write here. They can write router, they can write switch. Why will I say this is a router? If for this to be a switch, maybe it does not have operating system inside. So anything you connect here is the same instruction. But when I install operating system, I'm just assuming when I install operating system, it has changed to a router. So what am I now saying? I'm saying that please, anywhere you see this device, number 1 should always go to cybersecurity classroom. Because if you must browse very fast, number 1 give you the greatest, highest speed. Number 2 should go to infotech because they are borrowing our internet. Number 3 should go to computer science because we don't want them to browse at all. They should just communicate among themselves, but they should not go to the internet. That is when it changes to a router. So we can configure a router to do anything you want it to do. This is a router, you can pass it around. As small as this device is, it can power, okay, I passed it around already. As small as this device is, it can power this entire university, as small as it is. As small as it is, can power the university. It's to simply tell this, when we log in, you will see it. It's to simply tell this device, number 1 goes to Senate building. Number 2 goes to student hostels. Number 3 goes to classrooms. Senate building should always browse. Students should only browse from 5 to 4. Classroom should browse for 8 hours in a day. So this can be a router. This can also serve as a switch. By simply telling it, everything here should work together. Whatever is plugged here should carry the same function with everybody. One device, various functions. That is router versus switch. Router versus switch. So this is an entire connection. This is how internet looks like. So I wanted to show this picture last where I've explained everything. So that when you see this picture, you understand it. Let's look at it and break it down. Company A, please, let's look at this. Company A, just watch my mouse, please. Company A has a switch here by my right hand side. This switch has how many computers connected to it? 3. Company A put a router here with another switch. 2 computers connected. On that router, whenever you see the word ISP, ISP means modem. ISP means Internet Service Provider. So when you see ISP, it is simply asking you, who is your Internet Service Provider? Which SIM card is in your modem. So this ISP is maybe MTN router. The ISP has taken you to what everybody call the internet. What is that internet? Information sharing. Just that. Company B has the same setup. Their own ISP is Globalcom. They go to what we now call cloud. On that cloud, several internet service providers are dancing along. Anything you are sending, you are just exchanging information among yourself. Nothing is happening. What we call internet is actually a set of computers communicating amongst themselves. I visit Facebook. Facebook has a computer in one office sitting down somewhere with an internet connection to that computer. So far I have internet here. I am simply trying to locate that computer there. So what I'm telling you in earnest is that all your pictures, all your information on Facebook, it is on one computer somewhere. So if someone wants to hack your Facebook account, it's just to go to that computer. Once the guy is sleeping on duty, what the internet will tell us is that Facebook is down. They will not tell us that someone or one battery went off. That is network. That is internet. Nothing else is internet apart from what I have explained. So the internet, like I've said, is a global system of interconnected computer networks. Finish. The system could connect schools, colleges, university. We would pause here for today because we have had a long day. When we come back, we will go into what is called IP address. Because for a computer to connect to one another, they must have a name. They must have